Hey, thanks, Titus. So I want to get started and give you a bit of a background on Kata containers, really just a quick overview of it. And before getting into that, I think it's important to kind of discuss what exactly is a container. Um, I know that many of you folks listening probably already know this and probably know a lot more than me, but uh, basically when I think of a container and containers at large, I think of two things. And isolation really isn't the top one. So really what I think about is packaging and kind of some characteristics of, what you can get from a usability aspect of it. So I see containers as a really nice way to package a workload and a way to be able to run a workload that has very low overhead and allows you to quickly scale up, scale down, and really kind of carve out your workload into individual pieces. But the other aspect that I do think about is isolation. And with a traditional container, really it's not any one technology, it's just a bunch of primitives from the Linux kernel provides. And the key ones being C groups, namespaces, and then several others that kind of do some filtering, like setcomp or mandatory access control, ways to really limit what a given process is allowed to execute. In combining each of these, you end up with pretty great coverage. You have kind of this idea that you're the only workload running on a host machine, but in actuality, you could be one of many different processes. So these are all great, but they're all kind of based out of the same host Linux kernel. So every single one of these, sharing that same kernel. So the question kind of becomes, what if you really don't trust the other containers or the other people or the other programs running on that machine? Are you willing to share that same kernel and everything else? You're kind of always a single issue away from potentially running into leaking of information or people getting ideas of exactly what you're running. So what we find is that for very security conscious people, defense in depth is kind of a great game plan. And with Kata containers, that's exactly what we're looking at providing. So we still do run a container, utilizing things like namespaces and C groups, but we do that within a virtual machine. In the context of Kubernetes, it would be, a pod would run inside of a virtual machine. So what we do is we have that second level of isolation. We have, a container on the inside, and the outside you're using the hardware virtualization interface, which is a much smaller interface and a different one. So each container or each pod is running with its own guest kernel, and then that is running on top of the host's kernel. So, in a sense, it's kind of highlighting what is Kata containers is that we're an OCI compatible runtime. OCI is the Open Containers Initiative. And what this provides is a way for us to kind of drop in and adhere to a standard such that we could be dropped in and work in place of existing solutions like run C being the de facto standard. So this is one of the key aspects of Kata from the very beginning is that we have to make this seamless. We can't have end users recompiling their container images, things like this, or changing how the way that they work. It should look and feel exactly the same as a traditional namespace-based container. Also, it's not just a project. Well, it is a project, but it's an open source project. So, we're in open governance. It's no one company. We have a lot of different contributors, which I show a little bit later. It is multiple architecture. So, x86, great. We've also added support for ARM, as well as PowerPC, as well as the Z series from IBM. And then we also, from the beginning, have had the design around being able to support multiple VMMs or multiple hypervisors. So today, the primary that what is on default is using QEMU on top of KVM. Last year, we also added support for Firecracker, also running on top of KVM. We also have a new one that we're adding support for right now, which is an Acorn, and that's actually a hypervisor itself. And there's a lot of interesting work around Rust VMMs and everything else. So stay tuned. There's a good amount of work going on for the next release to support additional VMMs. So I mentioned this in the previous slide, but just to kind of reiterate that it's an OCI compatible runtime, which means if you're using Docker, if you're using Kubernetes, or anything really, it should just work. So digging into the Kubernetes use case itself. So if we look at like a single node, what you have is kubelet running, who essentially is controlling once a workload gets scheduled, kubelet is going to kick in and kind of control and protect the node and run the workload and everything else. But really, it's not doing a ton itself. It's going to call down into the CRI. So CRI is a container runtime interface, and Docker Shim is a traditional one, or maybe the common default today, but there are additional ones like Cryo, as well as Containerd. This is who's actually going to say, the workload schedule, we're saying go, we're interpreting the different commands, but Cryo or Containerd is going to pull the image, prepare the volumes, everything else to run it. But even Cryo or Containerd don't do anything with respect to running the actual workload. What ends up happening is it's going to call down into an OCI runtime. So the canonical default standard would be runC, but what we are providing in our project is an alternative, Kata runtime. And what happens is, depending on the runtime class, which I get into a tiny bit later, you would say, I want to run with runC. Or you could say, for this workload, I want to run with Kata. So I want to run it with just namespaces. I want to use a VM and then namespaces. And then what you end up having, and those runtimes themselves will actually start up the pod. So you could have the same exact workload, your same images, your same two containers, your same pod spec would be running, let's say, within Firecracker VMM. You could run one within QEMU VMM, as well as just on the host using traditional namespaces. So that's kind of what the total stack ends up looking like in a Kubernetes situation. So from a user perspective, what you would see is that you have runtime classes defined. So runtime classes are a way to specify, what is going to run and handle execution of the given workload. So this key value pair is saying, I would like to use runC as the default you could specify. Or you could have different runtime classes for, let's say, using Kata, specifically using Kata with the QEMU VMM, or you could have another one defined for Firecracker. And this is part of the pod spec. So if you had just two simple, pretty lame workloads, and were to look at the difference, the only difference between these two being runtime class being defined, get them again at the top of the pod spec. So one of them would be using Kata, the other one doesn't have it specified, so it would use the default, which in this case would be utilizing runC. And they apply the same, they're pulling the same exact images, everything else. And if you were to sit there and look at it, if you would see that they run. So they look like they behave and you interface as a user the same exact way, whether you're using a traditional namespace or if you're leveraging runtime classes. And again, you could specify a third one to say Kata with Firecracker, or you could have a fourth one for gvisor, etc. So that's utilizing runtime class. And one thing that I really want to kind of highlight with this is that these are complementary. So we're not saying, oh my gosh, runC, it's not secure, it's crazy, hide your kids, everything else. It's just saying that depending on the sensitivity of your workload or how much trust you have in the environment, whether it be trusting third-party container workloads or just things that are kind of more alpha level quality in your sensitive production environment, or anything else, you may want to leverage sandboxes in this case. If you don't trust that workload, put it in a sandbox and protect the rest of your system. So who is Kata Containers then? I kind of mentioned before that it was open governance. It is an open source project. This is one of the things that I'm most excited about is the kind of variety of users and contributors to the project. So we have an architecture committee that has folks from Intel, Huawei, Ant Financial, as well as ARM. But on top of that, we have a lot more people who are making contributions in all kinds of different ways. There's a list there. There's a lot more. This is just kind of some of the key people that come top of mind as I'm writing about this. Stepping back and looking at we understand what it is from a user perspective. Okay, it creates a virtual machine. Great. I don't have to change anything in my workflow. If you're curious, what is it actually doing underneath? So this is a bit simplified, but if you're using Kubernetes, you have a CRI, or this could even be Docker command line. Basically, something like an OCI command will come down and will call into Kata runtime. So Kata runtime will see that, and the first thing that we're going to do is start up we'll start talking to the VMM or start launching a virtual machine itself. That virtual machine is going to launch its kernel. So we have like a minimal guest kernel that's included. And we're going to start interfacing using vsock. But the first thing, and really the only thing that comes, the kernel is going to boot and we're going to user space. And the only thing that's going to run there is an agent. So this Kata agent, this is kind of like what runc would be on the host. In fact, it's using libcontainer, which is the same library that runc is based off of. And what this is going to do is it's actually going to do the work of launching the container workloads inside the virtual machine. So we have a gRPC protocol defined, and that's how the Kata runtime will talk with the Kata agent, saying, here's the container information, essentially passing the container spec in. And that's going to go over vsock as the medium. And the agent will go ahead and launch that container, again, using namespaces, C groups, things like this. There'll be like a standard I/O path, so if you have like an interactive terminal, anything like this, it'll come out over that vsock, and it'll be made through Kata runtime. It kind of acts as a shim for what is running inside the virtual machine. So Kubernetes or whomever above the upper level orchestrator will be able to interact with it using signals, and we'll get the SDIO that it would expect from a container as if it was running on the host. And if you're running to a container pod, they would get another OCI command which says run this one as well, given this sandbox, and it would go through, and the standard I would come back in just the same way. So a couple other just plumbing bits, which is really all Kata is just a lot of plumbing. Traditionally for most CNI plugins, you end up kind of dropping a veth into a network namespace, and that's how the container gets networking. In our case, we need to connect this veth to a virtual machine. And the way we've done this in the past, we started very early on. Bridge was a pretty naive, easy thing to do, but it adds latency. Mac VTAP we used for quite a while, but we saw that it was a bit complicated, and we kind of saw that traffic control is actually just about as performant and is a lot easier as far as just kind of mirroring in all the different route and rules and everything else into the virtual machine. So that's what we're using today. You can use SRV, you can use other configurations as well. So. And then how some of like the volumes and everything else are passed in. The answer kind of is it depends. Early on, we're using 9PFS if you're using kind of like an overlay or any way of like kind of just proxying the file system, which it has severe limitations. I would never personally want to use that as the default. But thankfully, we had a lot of good contributors. A bunch of the folks from Red Hat contributing and creating essentially VirtuoFS, which is a much better fit for exactly what we're doing in Kata containers. So this is experimentally offered now, though I would say that it's probably in better shape than you would have with 9PFS already anyway, from a security and maintenance standpoint. The alternative would be if you use block devices. So if you use like a device mapper based snapshotter or a graph driver or whatever to get the actual container workload into your to get the container workload. This fits very well with Kata just because you're creating a VM, so using Virtio block is well understood, well supported, and performant. Similar on the volume side, if you're just sending a file system over, it'll end up using something like VirtuoFS. But if you are able to pass in either network attached, great, or if you're doing kind of like a block device available to the container, then this again is a very native, easy way for a virtual machine. So depending on your configuration, you'll either be using something like VirtuoFS or VirtuoBlock. I think when configured well, they both are similar from a performance standpoint at this point, just because they're both using Virtio. All right, that's all the content that I have prepared for today. I hope that this helps give you an idea of exactly what Kata containers are and some motivation on what we have for working on this project and what it can do to help better isolate different workloads on your system. So if you're curious to learn more, you can find us online over at katacontainers.io, but you can also find us at all the usual places on GitHub, IRC, Slack, and everything else. I'm going to go ahead and throw it back over to Titus, who's going to show how Kata Containers is integrated into termed Kubernetes. Thanks.